In this video, we're going to look at a tricky compound area question that's suitable for those students aiming for a grade 9 in their GCSE maths exam. In fact, this particular question appeared on an Edexcel past examination paper in 2022. And as you can see from the examiner report, the principal examiner stated that very few students showed any understanding of what was required to find the total area of the two shaded regions. So I think this is a particularly good example of a question that can differentiate between the top candidates. So the question states that the diagram shows three circles, each of radius 4 centimeters. The centres of the circles are A, B and C, such that ABC is a straight line and AB is equal to BC, which is equal to 4 centimetres. Work out the total area of the two shaded regions and give your answer in terms of pi. Okay, so let's start by taking the diagram out and then thinking about how we're going to work out the area of the shaded region. Well, there are a few different ways in which we could solve this question, but because they're very similar to each other, we'll just look at one particular method. So in order to find the area of the shaded region, we could first find the area of the circle with centre B and then subtract the area of these two regions. And these two regions can be split into 4 sectors and 4 segments. So the area of the shaded region is then the area of the circle with centre B minus the area of the 4 sectors minus the area of the 4 segments. So let's first find the area of one of these sectors. To do this, we need to know two things: the sector's angle and its radius. And we've already been given its radius because the question states that AB is equal to 4 centimeters. So we just need to find its angle. And to find its angle, notice that we can create a triangle from the sector. And this triangle has sides which are equal in length. We know they're equal in length because two sides are the radiuses of the circle with centre A, and this side is the radius of the circle with centre B. And we're told that all of the circles have a radius of 4 centimeters. So we can conclude that this triangle must be an equilateral triangle. And so all of its angles must be 60 degrees. And we can also say that these two segments must have the same area due to the symmetry of the circles. Now, if the angle of the equilateral triangle is 60 degrees, then we know that the angle of the sector is also 60 degrees. And the area of a sector can be found by using the formula area of a sector is equal to theta over 360 multiplied by pi multiplied by r squared, where theta is the angle of the sector and r is its radius. And so for this sector, we get 60 over 360 multiplied by pi multiplied by 4 squared. Now 60 over 360 cancels to a sixth, and 4 squared is equal to 16. And 16 multiplied by a sixth is 8 over 3. So the area of the sector is equal to 8 pi over 3. So we now know that all the sectors have an area of 8 pi over 3. And all we need to do now is find the area of the segments. And as you can see, we can find the area of a segment by subtracting the area of the equilateral triangle from the area of the sector. And the area of a triangle can be found by using the formula area is equal to a half multiplied by A multiplied by B multiplied by sine C, where A and B are the radiuses of the circle with centre A, and C is the angle in between, which is 60 degrees. And so we have area is equal to a half multiplied by 4 multiplied by 4 multiplied by sine 60. And sine 60 in exact trigonometric form is equal to root 3 over 2. And so the area is equal to 4 root 3. And because we now know the area of the sector and the area of the equilateral triangle, we can find the area of the segment by subtracting the area of the triangle from the area of the sector. So the area of the segment is equal to 8 pi over 3 minus 4 root 3. Okay, so we've now found the area of a sector and the area of a segment. So we can now find the area of the shaded region. Well, we have 4 sectors in total and 4 segments in total. And so the area of the shaded region is equal to the area of the circle minus 4 times the area of a sector minus 4 times the area of a segment. And so we get pi multiplied by 4 squared minus 4 times 8 pi over 3 minus 4 times 8 pi over 3 minus 4 root 3, which gives 16 pi minus 32 pi over 3 minus another 32 pi over 3 plus 16 root 3. And so we have 16 pi minus 64 pi over 3 plus 16 root 3, which gives minus 16 pi over 3 plus 16 root 3, which can be written the other way round as 16 root 3 minus 16 pi over 3. And so the area of the shaded region is 16 root 3 minus 16 pi over 3 centimeters squared. Okay, so that's how you answer a particularly difficult compound area question that's suitable for those students aiming for a grade 9. If you found this video helpful, then please click the like button. And please also consider subscribing to my channel where you'll find more aiming for grade 9 GCSE maths videos. Thanks for watching.